Good morning, Honors Period 4. I'm going to do a review session for the systems quiz tomorrow. Just for your information, I have posted in Canvas the answer key to the review that I gave you on Friday. If you go into Canvas and you go into modules, I believe I put it under a new module called Systems, and it's at the bottom of the page. I believe that's where I put it. Okay, so here we go. Number one, you're going to solve this problem by graphing, and I will try to do a couple of each kind of problem that you'll see on the quiz tomorrow, so hopefully that'll help you prepare. Alright, so pause the video and try this problem, and then come back and watch me and make sure you did it correctly. Alright, so the first thing that I notice is both of these equations are already in slope-intercept form, so I don't have to actually move them around or anything like that. So in the first one, the slope is -1/1, and the y-intercept is 3. And in the second one, the slope is 1/1, and the y-intercept is -3. So if we graph both of these, hopefully we can actually very easily find the answer. Alright, so the first equation, I'm going to go up to 3. And then I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. We'll see if that's actually enough places. I may have to come back later and fix that. The second equation, I'm going to go down to 3. And I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. Now, it appears they cross at 3, 0, but of course I'm going to check that because my graphing may not be as accurate as I like. So we're going to suppose the answer is 3, 0 right now. If I plug these into the two original equations to check them, I get 0 equals -3 plus 3. That one checks. We're good there. And on the second one, I have 0 equals 3 minus 3, and that one checks. So I know the answer is okay, so the answer is 3, 0. Alright, here's problem number 2. And again, I want you to solve it by graphing. So pause the video and try it and see what you come up with. Alright, so as I look at this problem, I notice neither one of them is in slope-intercept form. So the first thing I'm going to do is I'm going to do some rearranging. So the top one turns into -y equals -2x plus 5. I divide both sides by -1. And I get y equals 2x minus 5. So my slope is 2/1, and my y-intercept is -5. On the second equation, when I rearrange it, I get -2y equals -4x plus 10. Divide both sides by -2. And we get the answer y equals 2x minus 5. And my slope is 2/1, and my y-intercept is -5. Now, at this point, some of you may already notice that I have the same equation, but let's suppose you don't notice that. And on the quiz, you still have to go ahead and do the graphing. So when I graph this problem for the first equation, I'm going to go down to -5, and then I'm going to go up 2, right 1, up 2, right 1. There's my equation, or my line. And the second one, I would do the exact same thing. I'd go down 5, up 2, right 1, up 2, right 1, and at that point, I should notice that they're the same line. So if they're the same line, that means the answer to this problem is all solutions on the line. Now, if they would have been parallel, it would have been no solutions. Alright, next problem, we're going to solve this one by substitution. So pause the video and work it out. See what you come up with. Just make sure you use substitution. Alright, as I look at this problem, I notice this one's really not a good one for substitution yet because it's not set up for that. If I were going to really choose what I wanted to do, if this were in the section of solve by choice, I would do elimination. But We're in the section on substitution, so I'm going to take that first equation and I'm going to solve for y because I can see that the y would be easy to get by itself. So I get negative y equals negative 2x plus 3. Divide everything by negative 1, and we get y is 2x minus 3. So I'm going to take that and I'm going to substitute it in the second equation for y. So we get 5x plus 7 times 2x minus 3 equals 17. 5x plus 14x minus 21 equals 17. 19x equals 38 when I rearrange and put all my variables and numbers together. Divide by 19, and x comes out to be 2. So now all I have to do is find y, and I can put it back wherever I want as long as I make sure I check my answer. So I'm going to go back up here to the equation y equals 2x minus 3, and I get y equals 2 times 2 is 4, minus 3 is 1, so supposedly y is 1. So I'm going to check my answer 2, 1 to make sure that it works out correctly. So in the top equation, 2 times 2 is 4, minus 1 is 3, so that one checks. Second equation, 5 times 2 is 10, plus 7 times 1 is 7. Does that equal 17? Yes, it does. So I know my answer 2, 1 is correct. Alright, let's solve this next one by substitution. Y equals negative x plus 3, and x plus y equals negative 1. Alright, solve this one by substitution, and then come back and check your work against mine. Alright, so this one's already set up for substitution, so I'm going to take my negative x plus 3, and I'm going to plug it in the second equation for y. So I get x plus negative x plus 3 equals negative 1. X plus negative x, that cancels out, and I end up with this 3 equals negative 1. So this is one of our special cases. And because my variable is gone and I end up with two numbers that are not equal, this one would be no solutions. Had I graphed this, these two equations would have actually been parallel. Okay, next method, we're going to use elimination on this problem. So pause the video and solve it by elimination, see what you come up with. Alright, this problem is already set up for elimination. It's perfect. We even have the same variables that can cancel out. So I'm going to add the two equations. And I get 6x plus 3x is 9x. Negative 7y plus 7y is gone. 21 plus 6 is 27. Divide both sides by 9. And x is 3. Plug back in and find y. I'm going to go the top equation. 6 times 3 is 18. Minus 7y is 21. Subtract 18 from both sides and I get negative 7y is 3. So y is negative 3/7. And of course, if I end up with a fraction, I always want to make sure I check it because that looks a little weird. So when I check this problem, 6 times 3 in the top one is 18. Minus, if I take 7 times negative 3/7, I know my 7s will cancel, so I just get negative 3. And is 18 minus negative 3 21? Yes. On the bottom one, 3 times 3 is 9, plus 7 times negative 3/7, again the 7s are going to cancel, and I get negative 3 equals 6. Is 9 plus negative 3 6? Yes, it is. So my answer is 3 negative 3/7. Alright, here's another one for elimination. So go ahead and solve it by elimination and come back and check your work against mine. Alright, so this one is nice and set up. The x's and the y's and the constants line up, but unfortunately none of my variables are going to cancel out. So remember, you have all kinds of options here. What I would probably do is I would multiply the top or bottom equation by 2. So I would get the top equation stays the same, 3x minus 2y equals negative 1. The bottom equation, 2x plus 2y equals 56. Okay, so I'm going to add my two equations. 3x plus 2x is 5x. Negative 2y plus 2y, that's gone. Negative 1 plus 56 is 55. Divide both sides by 5, and x is 11. Okay, I'm going to solve for y by plugging this back in. So I'm going to use the second equation. 11 plus y is 28, so it looks like y is 17. And I get 11, 17. Okay, let's check it. 3 times 11 in the top equation would be 33. Minus 2 times 17 would be negative 34, so we have minus 34. Does that equal negative 1? Yes. And in the bottom equation, does 11 plus 17 equal 28? And yes, it does. I get a final answer, 11/17. Okay, we're going to do one more, and this is one of those that I'm going to make up, so I don't know how bad it's going to be. Kind of hoping there's going to be fractions or something, just to show you, you know, how difficult they can get. Alright, so here's the problem I made up. 4x minus 3y equals 12. 6x minus y equals negative 8. And I'm going to tell you, you can solve it whatever method you want to use. So pause the video and use whatever method you want, and then come back and check your work against mine. Alright, so I've told you guys before that I always choose elimination just because that's the method I like the most, but this one would have been an appropriate one to also use substitution, because that second equation would have been very simple to solve for y. So I'm going to multiply the bottom equation by 3. So I get 4x minus 3y equals 12. My top equation is going to stay the same. My bottom equation would be 18x minus 3y equals negative 24. And it looks like I probably need to subtract these two equations, because negative 3y minus negative 3y is become 0. So when I take 4x minus 18x, whoops, lost my pen, 4x minus 18x gives me negative 14x. And when I take 12 minus negative 24, I get 36. Divide both sides by negative 14. And I get a lovely fraction. And I get, let's see, 18 over negative 7. Okay, that's what I wanted. I wanted to have an ugly one. Alright, so let's plug this back into the top equation and solve for y. So I have 4 times negative 18/7 minus 3y equals 12. So that gives me negative 72 over 7 minus 3y equals 12. I'd probably eliminate my fractions right now. I'd multiply everything by 7. I get negative 72 minus 21y equals 84. Add 72 to both sides. And we get negative 21y equals, let's see, that's 156. Divide both sides by negative 21. And we get y is, let's see, I know those divide by 3 at least. So 156 divided by 3 is 52 over negative 7. And I think that's it. So my final answer is 18 over negative 7 and 52 over negative 7. And I would say we definitely need to check that one, because that one's really ugly. Alright. Alright, so I came to the next screen just so that I could actually check it. I didn't have any room. So when I check this problem, I have 4 times 18 over negative 7 minus 3y. Oops, nope, I got to actually plug in my y. Forgot about that. Negative 3 times 52 over negative 7. And we're going to see if that equals 12. I have no idea. So in the first one, we have 72 over negative 7. And we have negative 3 times 52 over negative 7. That's going to be positive. And it's going to be 156 over 7. Alright, so it kind of looks like I have, let's see, this would be a negative right here. So I have 156 minus 72. So that looks like that is 84. So 84 over 7 is that 12. Yes, that one checks. Okay, so we know the top one checks. All right, in the second equation, we have 6 times 18 over negative 7. And we have minus y, but y is negative, so that's going to be minus a negative 52 over 7. Does that equal negative 8? Well, 6 times 18 is, let's see, that's, can't really do that one in my head. 108, so that's negative 108 over 7. Minus the negative is going to be a plus, 52 over 7. 108 minus 52 is 56, so that's negative 56 over 7. Is that negative 8? Yes. Okay, so our answer checks out. This is our final answer. Okay, so hopefully these problems that I did for your review will help you, and you'll have your quiz when you go in on Monday, and I will see you on Tuesday. Have a good day.